So our next presenter is Dr. Andrew Caplin, and he is a professor of economics at New York University and also the co-director of the Center for Experimental Social Studies. And I read about his research interests on his biography, and they're very, very diverse, and I only understood what about half of them were, so I had to Google the rest. But relevant for today, yeah, I know. But today, he's going to be talking a little bit about a theory of learning and attention for evaluating skill elicitation experiments.
So I particularly want to thank the organizers for inviting me here, because bluntly, I'd never really thought about these questions until being asked to think about them in the context of this conference. And the particular angle that I'm taking is a measurement angle, measurement and modeling. And in particular, I'm going to be focusing on how you model and think about the role of attention first in the early stage of learning and then in the second stage of taking a test. In the process, I discovered that even in the simplest test that I could imagine, the one that's standardly taken, I don't know what we're inferring exactly. I understood that. I began to kind of write down what I would like to infer and understood I couldn't infer it because there's so many things are getting mixed up inside the choice of how to answer a question. So this is, in fact, picking up exactly on a theme of Dan's, the issue of identification of preferences when you don't understand the beliefs is so overwhelming that it really makes the inference challenge hard. And what I'm going to end up with is a particular suggestion for a class of very trivial experiments that might be clarifying. So let me just go over this. Okay. I'm going to pose 4 basic abstract questions. I don't know where 5 came from. First one, I just wanted to write down for myself. A big 5, I was thinking about it. Subconscious.
2 will come from
Why? Why did you do this? How well does a standard multiple choice test with standard grading measure skill? Simple question, you would think. Surely that's what we do all the time. We must have some theory of why we're recovering skill, whatever that is, from the answers to a standard test. And breaking that down, I figured out that I didn't understand how a standard test is answered. I don't know what guides the answers to the test. Therefore, I don't know what to infer from the test. So I'll just show a few examples where I'm like, is that what they're revealing? Why is that called skill? Okay, so I'm an economic data engineer, meaning I did do economic theory. I got kind of stunned at the fact that I was supposed to stop there. And that was a profession and perfectly honorable one all by itself. And I kind of kept on saying could be to myself. And I would walk in a seminar and say could be. And then, can I leave now? It could be. And so you want to know is what's the right way to pursue? And then I started interacting with people who had data. And I say, good, let's test this theory on that data. Then it turned out the data wasn't good for testing the theory. Then I spent my time gradually maneuvering to a situation in which I could generate the data with which to test theories. But I found that changed the theories. So the 2 things co-evolve, and that's by far the most interesting place to be. All right, how might enriched measurement and grading improve skill measurement? Very simple question to which I have no answer. But I will talk about 2 things you might do, and I'm sure they've been done in various ways. Elicit information about the confidence in the answer, not just what is the answer. So maybe you'd like to know, did you guess that one? Or were you pretty sure on that one? And you could elicit information about or restrict the allocation of time and use it in the grading algorithm. It's one thing, because that's a very intricate problem, the division of time. And certainly it's the case that in the kind of things that Dan's doing and the kind of things that Armin's doing, you just let people have one question at a time, which they then answer. If I give you this whole book and I don't restrict the order, wow, we have a very, very intricate problem on hand. Okay, question 3, how would changes in measurement and scoring impact learning? Presumably the point of this is somehow to tighten up some ex post assessment based on the measurement, which then is supposed to incentivize the prior phase of learning. And even just modeling and writing down what that meant has got me confused. I'm going to illustrate what goes wrong in a standard multiple choice test just with a few simple examples. What can go wrong? In the simplest reasonable model, mapping from beliefs to answers is going to depend on the scoring rule and the utility function. If I get penalized heavily, I'm going to answer differently based on whatever I believe at that point. In the simplest reasonable model, if I open you up to walk back and forward through the exam, the optimal allocation of time problem is essentially insoluble. I don't know, how much should I give to a hard question? When do I cut and run? Who knows? And in a richer model, obviously you're going to get things like anxiety playing a role. So now we've got a very multi-determined. Okay, I'm going to give reasons for optimism. In the simplest reasonable model, allowing elimination, saying, look, I mean, you may not know which is correct, but maybe you know some that are incorrect. So let's get rid of those. That would help. Eliciting beliefs would be much better if you could do it. So I'll just talk briefly about that. In the simplest reasonable model, much would be learned if you actually knew the allocation of time and measured it. Measuring both together would be even richer and could include the adaptive testing in vertical learning environments. I mean, you then begin to think about it, say, what's a test of? Or sometimes it goes from simple to hard. Sometimes it's just a bunch of stuff. So you need a model of the technology that they're very different types of tests to design. Okay. And now, the question of how to impact learning, I think is reasonably conceptualized as roughly the following. In a given exam, the test taker, who has by this point fixed some actual skills, that's called a cognitive capacity, because they've invested ahead of time, they built this character, must map from prior learning to distribution of possible scores and corresponding utility. I mean, that's a tough challenge. You've got to think about what I got from all my learning, and that depended on the test. Okay, everything here is complex. Really hard material to think about what the problem is, even specified, and what's the learning. And the only thing I'm going to tell you is that this is the only place where I definitely know something already, which is, this is a question that might well be modeled by a new class of models that's coming into economics, which are rational inattention models, introduced by Chris Sims, Mike Woodford, Mateko Mackay, and myself and Mark Dean have studied aspects of this. And it says, actually, in the end, the other thing apart from the utility function is a mental production function. That is, we're trying to model an input-output, the mind as an input-output device. And we'd better be a little clear about what the inputs are that we're trying to get from it and what the outputs are. And we're going to then write down the different transformations of inputs to outputs at different costs. Those things, those cost functions, basically production functions, turning inputs into a stock of cognitive capacity in some form, is the thing that we'd like to call a skill, although exactly how, whether it's the level that you achieve or your production function, is a very interesting question. I don't know, so I didn't get an answer to the question what a skill is at all. I'm just giving you some conceptual apparatus. Okay, and I'm going to just at the end propose a class of laboratory experiments before doing field tests of test redesigns to see if they are clearer at measuring a skill. And the fix is going to be that in this experiment, you will manipulate the skill. It's the experimentalist who will set the skill level. And it will be that the test is trying to recover. And if it fails, then it just wasn't good at recovering that skill. Okay. It's a bridge too far to design this optimally in a mechanism sense. I'm too confused about what the objective is. Okay, first thing, how do you answer a test? What is a test? Well, I think it's got three things, three parameters. T, the number of minutes to answer all questions. N, the number of distinct questions drawn from some background set of questions. And K greater or equal to real answer options per question. That's an abstract multiple choice test of a very standard form. Yep?
What about item difficulty?
Pardon?
What about the difficulty?
That's drawn somehow from Q.
Okay.
And I haven't specified the drawing of these questions from the set of conceivable questions hanging out there in the background. Okay. Now, my action set as a decision maker, the test taker. For each question, I can pick 1 through K or not answer. That's all I can do. The actual answer is going to be something, again, drawn from the book of good answers. That is, we've got this massive universe over here called questions, and this massive universe over here called answers. They're both written in words. And I'm just going to pick out a set of answers, stick them down, and they'll correspond to picking a particular answer to a particular test. I guess to make it a multiple choice test, there should be a unique correct answer by star of n. If not, we're in deep trouble for each question. And typically, one assumes the test taker walks in completely ignorant about whether they will assume that this was randomly assigned. It's not that I can guess, if I guess the first answer, that's really systematically going to win something for me. Okay. All right, what does the person do? They put a standard answer is something which lists either for each question, either I didn't answer it or answer K. I tell you which one I picked. Then I put a standard scoring rule down on it. The standard scoring rule will take the vector answers into a score between 0 and n, which basically standardly count the number of correct answers, count the number of incorrect answers, grade based on a weighted average of the correct answers, subtracting some penalty for having got an incorrect answer. And don't let it go below 0, and that's about a standard grading of a standard test. Yeah.
It seems like this extends easily to multiple correct answers per question, but that map into different personality traits or whatever.
Yes, I'm just trying to describe the world's simplest test, the ones that my daughters take every single day. And if they weren't designed like this, there's a problem because they claim they're designed like this. Find the correct answer to this question. Now, I can, as an individual, presumably if I understand the test, which is a big question, do I understand the grading scheme? But let's imagine I do. I can map into my choice of answer, but I've got to think about what do I learn about an individual from looking at a vector of answers? That's the only question, and that's all I'm trying to do. Like, that's all I got. All right, and here we enter the realm of theory. I don't know what I learned. It depends what drove the answers. Now, what has to drive the answers? In the simplest reasonable model, we'll have a Bayesian maximizing expected utility of the final score. They'll think there's some good score. I'd like to pass. 70 is a passing grade. If I get above that, it's okay. Of course, I'd rather get 80. But there's a big problem if I don't get 70. So it's not a linear function you expect of their score. And then there's a failing grade, etc. Now, the choice. Well, I think The object on which it must be based in a classical simple theory is the posterior belief over the vector of correct answers at point of completing the test. There's kind of nothing else that matters. And I'm doing this vector-wise. I'm imagining that you took the entire test, you sat there, you took stock of your beliefs about the answers to each question, and on the basis of those beliefs, you selected the answers. That's actually a remarkably, even at that static level, that's not a trivial problem, given the nonlinear utility function. It might be, for example, that there were correlations induced in the probability of making mistakes. For example, you thought there were 2 different ways to answer a type of question. There were 7 of that type of question. Do you use technique 1 for all 7 of them because you think it's more likely to be correct? Or do you diversify and say, listen, I can afford to get only 4 wrong, and I can afford to get 4 wrong, not 7. So I will divide 4-3 with my answer algorithm. So it's non-trivial. This treats it as if you also answered all of them at the end. In practice, and this is equivalent if you went back and changed everything at the end in light of the correlations that you noticed. But you can't know the correlations as you're going through the test, because you don't know how many other questions are going to depend on the same algorithm. So it's much more complex if you're going through sequentially to know how to answer these things. You may have to go back and correct. So I don't know what belief drove me to make a particular choice. The simplest would be the independent case. These are all independent answers. Even here it's not entirely trivial. I find surely I'm going to pick one of the maximizers in each answer, one of the most likely elements that I have. But how many of them before I start guessing? Before I start not answering? That depends on the penalty and the utility function. So it's just, okay, this is not trivial. When best is it not to answer? Well, there's a satisficing rule. I'm more than 90% sure I answer if I don't, but that's not optimal. But I don't know what people do. I literally don't know what people do. But in the end, I mean, that defined a complete mapping, a risk averter. A risk averter has a very complex problem. A risk averter, even in the independent case, has good reason sometimes to choose not to answer a question. Because I have the penalty. I could subtract a little bit, I don't want to answer it. I'm 90% sure what the answer is. You can give easy examples in which a dominant strategy not to answer a question, even though you're 90% sure that you get it right, or 99%. Okay, you can do it. With correlated answers, you get this choice between fudging and diversification. And it's, okay, you may need to change your prior answer. Well, that was the trivial version of the question, because we haven't yet dealt with how much time I gave to answering each of these questions. All right, so in the drift diffusion model, classic, not with 3S, but anyway, Radcliffe, and it's been well studied that there's this tendency as you put more time into a question, you get better at answering it a little bit, and you're more likely correct. So now we're going to divide up our time. But we're going to do so in a forward-looking direction. How else do I do this? I'm going through it, and I've got to think, okay, this one's difficult. I don't think I'm getting much bang for my thinking buck here. I'd better move on. So now you go to a stopping rule of some form, takes you to the next question, and then you have some presumably return rule, which you might forget. It can depend on how expert you are at this strategy. I mean, the time allocation strategies vary hugely and are now being tested for. If you've been taught that you go through the test and you do the easy ones first, whatever you find easy, get it done, then you've got the rest of the time, that's good. If you haven't been taught that, or if you're the type of person who gets perfectionistic, I'm sitting at a question 3, what really happened is the examiner got it wrong. That happens. The examiner got it wrong, and you're looking at this question and you just can't answer it. You're going to do very badly on that test. But that had nothing to do with your skill. In fact, it was the opposite. In a simple experiment with Daniel Martin, we gave people a test in which it was subjectively very difficult to know the truth. The way you can do this is you just write down, here's a bunch of numbers. This number is 17, and it just disguised it by writing it as a complex sum. It's 16 minus 23 plus, and then I can square it if I'd like. It's a number. So if you did the operations, you'd know what this was. It's perfectly obvious what the correct choice is to a machine, not obvious to you. You tend to look at those things, take a look at the sum, say, oh my God, is this one a hard one or an easy one? What we found was bimodal. Some people would jump out, you take a look at the question, say, this is tough, I'm gone. Take a guess. And the other ones you give real time to and you do much better as a result. But now we've watched the algorithm being in use, not the skill, well, unless the skill is the algorithm. What's the best stopping time? I don't know. It's essentially an impossible dynamic programming problem. What problems are coming next? I have no idea. They're drawn from a question distribution. I'm walking through this exam. I don't know what I'm doing. And I can't really know it. And how early problem impacts later performance may depend on things like neuroticism. It might just be that. Okay. What then to infer from success? Look, I don't know. I don't know what to say about the score because I've told you 7 different things that could have gone into shaping the score. And even in a case in which I told you, in fact, there was a fixed capacity underlying this, a skill at this operation, I don't know, I certainly did not uncover it. I uncovered lots of things, like maybe your utility function, which I equally can't see. So I agree with you, I can't see that utility function.
Andrew?
Yeah?
Quick question. I understand what you're saying with respect to interpreting a specific outcome. I assume that people differ in terms of how precise the signals they receive in answering questions.
Right.
Call that knowledge or whatever, right? Some are better informed, others are less informed. How robust will the test that suffers from all these problems detect a rank order between the signal strength people have? So if you would interpret it as this guy is better than that guy, how robust will it be in the rest of these problems?
Could be lousy. I can give you a distribution over strategies that is that happens to go against the distribution over skill, and I'll get you all to score the same, but there were massive differences in skill. In other words, I can just write examples down where you can clearly see.
So not relative comparison.
No, it all depends. It depends. If everything is independent, that's fine. But if these factors are not independent, and you just added so much noise, was it necessary? That's an interesting. Was it necessary to do to take a very simple thing you're trying to measure, something you call a skill, even if you happen to know what that is exactly, and you've taken it through this massive transform involving utility, strategy of time, and strategy of answering.
Let me ask you a question. I understand the test, the score itself is not going to be a very good statistic. But you suggested a series of other things.
Yes, I'm just going to go into those now.
So you can condition on those. It's not analogous to what I was talking about yesterday.
Or score, or you condition on them, yes, or use them.
Use them as a separate mission, right?
Yeah. Part of the score is,
You can still extract the skill, right?
yes, so the whole game would be, can I now redesign, it's a little bit, it's heading toward mechanism design, can I redesign a test
Right.
that will do a better measure of measuring the underlying factor, which I'm going to imagine is nice and scalar.
Or that I would vary the parameters in such a way that I could, even though I know there might be differential effects going on, but I could imagine standardizing for it.
Yeah, an identification exercise carried out well ahead of time.
Yes.
That you've tested this out and you've done it. So I'm just going to describe roughly a program that might do that or begin beginning.
Well, let me ask just a factual question. I thought like an IQ test, there was something about speed that was also coded in addition to sort of the correct answer, right? I thought there were additional characteristics of the timing, just in terms of your analogy.
Well, there's
asking a factual question of
a
psychology.
huge literature now on using response time as to augment the score quality. For example, Wim van der Linden led this research that suggested how this kind of time information could be used to get better estimates.
I'd love to.
I've got to catch up.
And he reviews the 100 years of research that's been done on this topic. So I think that it really is functional stuff.
Good, so if you wouldn't mind emailing me.
One of the findings, this goes back to 1920, was that the definition of a so-called power test was that you get the same scores under time limits and no time limits. And that's the kind that characterizes what we typically use in something like the SAT or something like that.
But you would claim that that you get the same, but how would you know you get the same recovery of skill? I'm just trying to. You're saying the same person taking the same test. How could you? I don't even know how you. I'd like to see the experiment that would establish confidently to me.
So you could imagine the design. It was okay. You have 30 minutes, and to Group A and Group B says you don't have any time limit.
And you find the same distribution?
And you find roughly the same distribution. Yeah.
For the same people?
For the same people, yeah.
No, but I'm just so you say
Within
That's-
subject test, though.
It's a within subject test. So you use parallel forms and all the
Anyway, there's
a lot.
Anyway, there's 100 articles on this
But-
kind of topic.
okay. So I feel I stand corrected. I now know that I have a deep well to go to. I don't know what I'll find in that well, and I want to keep going.
It's all well and good.
Can I ask a clarifying question? Is there a literature in which you tell the person that you're testing that the score, the time is going to be part of the score?
Sure.
Or there is? So that has to do.
And we did an experiment last summer.
And the confidence, can you ask subject the confidence?
Yeah, there's a big literature on that too. Author Stan Coffman's written a lot on confidence. The finding on confidence is basically confidence is a factor. This is kind of a weird result, but independent of proficiency. In other words, there's such a strong sort of confidence
But you can do-
characteristic, but it's uncorrelated with how well you do. Some people are very confident, regardless, they don't do very well, they're very confident.
But that,
I'm asking whether you can tell the subject. If you are not too confident, if you give me that, then I will keep that into account when I write.
Yeah, Bruno Di Finetti himself, back in the 1960s, had this scoring scheme where it's multiple choice like this, and he said, you have 10 chips. If you really think strongly, put all 10 here. If you have no idea, spread them out equally. And when people in the Netherlands tried this out, what they found was that he had to be at least at university level before figuring out how to do the scoring was easier than answering the questions.
that's very specific to the fact that we've decided that this isn't essential to testing. If we had decided that this measurement was essential to testing, we would have done homework on it, and people would have nailed it some time back. So I'm going to now imagine that it's still an open design question how to use them in the grading of a test. I'm going to imagine that.
But can I just say, so there's one other literature on speed accuracy trade-off, right? There are deadlines and no deadlines. And so one way to control it is to create tight deadlines. So you can get rid of that decision component of whether to persist longer.
Yeah, I don't yet look for an answer. I'm willing to spend my time opening the question in a way that leaves me as more confused at the end than I was in the beginning. That's fine by me. And you're telling me, and I think I believe you, that there are what I would consider to be partial answers to be found to some of the questions, and that's the way I'll treat what you're saying. That the people are ahead of me by far, I'm just opening empty boxes. People are ahead of me by far in filling in some of these boxes. Whether I would consider that the boxes have been fully filled, that's not the type of person I am. So the answer is no, I can tell you right away. Let's keep going and we'll see where I might. Okay.
Wait, before, wait. Can you circulate away? Excuse me? Before it goes away, in a reading list, you circulate.
Yes, that would be really fantastic. I agree.
What's that?
Will you circulate a reading list?
Okay, so we've covered about 3 literatures, all of which are
Well, 3 reading lists.
3 reading lists. So I have to write this down. Which ones I found?
Let's keep going. So we're going to ask you
for about 4 or 5
more.
But speed, accuracy, trade-off, confidence, and
So, let's just start expanding measurement. This is the kind of engineering thing, which is what's the right thing to measure and feed back into the score. One thing is very trivial. I'll occasionally allow you to use multiple answers. This is a little simpler than the 1090. But the next thing is the 1090. The next thing is the 1090. I'd like you to put down a belief of the accuracy of this answer. I promise you that people could do it if that was a subject and it was taught, people would be pretty good at that particular thing. Now, and you could even use a BDM mechanism, an experimental mechanism, to make sure that when they wrote 0.6, they understood that a random ball would be drawn for one of their questions. If the number came in below 0.6, their answer would be used. And if the number came in above 0.6, then a 0.6 lottery would be used. And they could be taught that it's a dominant strategy to say what you believe. So now you have potentially a belief. Now that is incredibly more informative. I don't think it's just that it's an uncorrelated factor and that's uninteresting. I think if it turns out that a person is 90% sure that they're correct, and they're correct 10% of the time, that's a good test statistic to find out. It's very diagnostic of a problem. And I don't know why we'd want not to have that as part of the assessment. So it's another factor, which is, are your beliefs based in reality?
well, it's Dunning-Kruger.
Pardon?
That's Dunning-Kruger.
Okay, I got another literature. My reading list is growing. I'm very happy with it.
But that's also related to measuring overconfidence.
Yes.
More standard.
I mean, just by measuring that, and I don't know if there's a literature, but I know there's a company that you actually change it. So somebody who would not reflect on whether they knew the answer or not know the answer, it actually changes qualitatively how they're taking the assessment and how they're learning when you even ask them the question.
I think that's very plausible and interesting, and in fact, it should, in the ex-ante sense, it should impact how they learn.
This guy who made $1 billion said it's the single most important thing they did in making their adaptive learning.
Last, I'm too late.
What do you make the next one?
Measuring beliefs have other interesting elements, which is you could separate eureka questions from gradual accretion questions. It might be that there are some questions in which, it's 0.1 until it's sign up. So, and other questions in which, as you let them go, that you're finding more and more. If I look at the time allocation, I'll do a better skill of it. And do some conditioning on the time allocation, or you can enforce order and remove differences in this strategy. I mean, depending on whether you want to study time allocation skills, which is a whole other question. Maybe that should be studied as a time allocation skill. Pure. Okay. And in adaptive testing, you could use these things that you're gathering, the additional measures, to further condition the next question to come. Like I'm finding out somebody who's overconfident and takes a long time to learn nothing. What do I do? What type of question comes next? Like, please spell your name.
All right.
Skill development. The ex ante phase is, now I want to give you kind of the modeling apparatus that comes to mind. You start looking at an exam with an ignorant prior. I don't know which of these answers is going to be any good. You end up with a more informed posterior. That, we believe, is the thing that's going to map to the choice you make. Your ability, in the classical sense, would be the set of posteriors that are feasible for you to generate while taking this exam. I give you an hour. Depending on how you focus and what you focus on, you can end up with a different posterior. Because you might focus on one question and get it for sure right. Or you might choose to divide your time up equally and get everything to point 6. Or you might say, here's a hard question, I'll ignore it. There's a whole bunch of things that impact the posterior you end up with. And you have to think, what resource am I using in trying to get there? And the thing about the rational inattention model, which makes it very nice, is that it's a cost function that costs up your ability to transform ignorant priors into informed posteriors. That's all it does. And the origin of the particular function that's most useful is Claude Shannon.
It's simply a
Measure of literally what's called Shannon entropy. You start off disordered, and you'd like to bring order to your answers. And therefore, you could actually solve an optimization problem, look perfectly ordinary, with a capacity level K that was set in advance. And that was what you learned for. You set the capacity with which to take this exam. Okay. Now I have a utility function which, because of my understanding and beliefs about the test, is going to induce a mapping from any vector of posteriors to my final expected utility. So that can all be done. And now I can find out the value of capacity in any given exam. And now all I need to do, the tiny little other step, is to take the distribution of possible exams, which is ex ante what I'm thinking about, some prior over those. That's the EU I'm facing in the earlier phase. Subtract out how difficult it is for me to gain capacity. Pick how optimally to learn in order to map effectively given my abilities from priors to posteriors. So you can describe this all as a classical optimization problem, bearing in mind the mental production function. And what the mental production function does is provide you the ability to transform priors into a set of posteriors. The more capacity you have, the richer the set of posteriors you could choose to achieve. Therefore, in principle, the better you do on every test.
What is that predictive function dependent inputs, preference parameters, my value of leisure, the difficult?
Yeah.
I think that some of these other parameters we mentioned could be costly. And so the Shannon measure, the measure of the production, would depend on the inputs themselves that are valued. So I don't know how separate.
The classical way of doing it is to take the utility arguments from the completion of the test on one side and say that however painful it might have been for you to do the learning, that's independent. It was a pain that you suffered independently of those rewards. Therefore, in the expected utility function, you can be subtractive and take out.
That's what I'm saying.
Yeah.
It might be natural to think of something where the two are interdependent.
Yes, you could.
Using some of the same inputs and more conscientious versus
Actually,
find
do
it.
it dynamically.
Yeah, might
Yeah.
find it easier, or somebody who's compulsive will find it much nicer.
Yes, so there's no question that the parameters. So in this,
But those are also better.
their parameters, yes, they may enter the utility function, they may enter the cost function. So you may have a very interesting set of issues, that there's an underlying set of characteristics, that when you think about it, they both impact what one would call the Shannon cost of capacity. That is because I don't like working. I mean, Oh, I love it. Yeah. And then somebody else, and then at the same time, it could be that that impacts the utility you get from the higher test score because you like your competitors. So there's no so if the underlying characteristic pool is under here, the decision problem splits up into a utility function and a cost function. And now we've got a really tough set of both design and inference problems. So rational attention theory was introduced into economics because we used to think largely in terms of going out and buying information objectively. That is, I go to a market, I find out the price of each item, I pay for the next market I go to, now I've searched two objects. So Stigler's theory of search is the origins of costly information processing. Rational inattention theory says I actually have no idea what you did. I don't see any of those intermediate steps. All I know is that somehow, through some work, you map from prior to posterior. And that is that reduces it closer to data on, let's say, actual performance. Okay, so that's kind of that. And the only thing is, the final thing I wanted to say is what might liberate further understanding. Well, here's a class of experiments that kind of struck me as intriguing. You set up a machine, it's quicker than another machine, an operation, which is the entire subject of this test. That is, time, just simply use time. Operations per unit time. The test involves a whole bunch of operations. Additions. I give they're very complex additions. You need to use an adding machine. I give one person a machine that operates literally with the following lag and spits out the answer. The other one, shorter lag, spits out the answer. Now I have no question what it is I'd like to infer. The speed of the machine from the data. When I actually do, I'm going to make one, and then I'll give you a large set of different tests.
Now what is the technology? Is it QBM correct? I mean, you have to go through all the operations correctly and then you get the right answer. Otherwise you get uniform distribution.
I mean, detailed algo. Right now,
this is very important.
Right now, I'm giving you a machine with a fixed skill. I'm going to design a task which requires that skill and whatever else that is the other inputs, such as your intelligence in choosing where to deploy that skill, as in a classical exam. That's the only thing this exam will need in practice, is skill deployment of this machine. And that's that. And now I know what the machine difference is. And I know that I might, in fact, be recovering other features of the, such as the algorithm that was used to deploy the machine. And that's about it. And now I want to know what data do I recover in order to infer that better. And could I design a test that better inferred that? And then now this is actually a person doing it. So it's a person using a machine, and the person's character might come in. Because a lot of things would happen with this. You could, in fact, induce various emotions by throwing in, let's say, if you wanted to trip my elder daughter up, it would be very easy. You'd throw in an incorrect question, number 3, and watch her score plummet. So this is really where I'm at. I think that is no question that richer measurement is needed. This is a theme of the next generation of work. We need to be measuring more than just I did X. Like, well, in what, how long did it take you to do X? What did you believe that led you to do X? And if we can start measuring those things, then our inference is much richer, and I haven't answered what a skill is in practice because I don't know. But I can tell you that I can understand at least this very crisp class of experiment and elicitation of one dimension of it. No.
But what if you wanted to, say, add one more feature, which is I wanted to predict performance on, say, the FCC or whatever. So I have a set of tasks that I want to list the skill I'm doing. And I can then sort of take the measurement, and then you also give the analyst the possibility of
Yes.
Observing how they do on some tasks after they're through with all this measurement scheme.
Yeah.
How would you modify it?
Well, I think what would
Does
end
that
up...
answer the question of the skill?
Yeah, that might end up being that, look, I can't in the end test this final worldly implementation of you.
Right.
But I can look at the worldly implementation as a function of everything I elicited. And now, when I need to, I can come up with a single number, which is determined by the particular value that this employer or this place places on this somewhat generalized skill.
Or a vector. You kept it all in track.
Yeah, absolutely. Yeah, so
Okay, so we have time for one question, but we are going to have another working lunch. Okay.
I'm just trying to understand, this experiment here seems like it's intended to, if I understand right, to reveal how little or how difficult it is to infer an actual skill, given all the other skills on the other influences on the test taker.
well, I'm thinking of this as something that could be used
By the designer of an exam
over here.
to say, I actually can confirm for you that our test measures this particular skill you
We're interested in, because I actually cheated and gave the skill to a machine. And in as much as, and we could tell, we know what we're trying to find out about that.
So it's really
About the mapping
from measurement to skill.
becoming a measured object. We could then theorize about it.
But I'd
Like that object to be measured. I mean, I think measurement precedes, apart from this very abstract theory, the reason I wouldn't go much further is I don't know how this will turn out. I'd like to read all the literature, but it's going to be in the experiments that we'll discover, you know, if we can separate out the vector. And if we could then say, look, I actually input a machine with 5 characteristics, and I recovered all 5. Well, that would be amazing. And then say, that's a pretty good test. I think you nailed me. And I'd say, Tim says, it might be that actually the fact that the exam order problem is a subtle problem. You might say, I got a hint that this person doesn't have skills directly down the speed line. Boy, you should have seen how smart they were in their strategy. And so I'm wondering, you know, so it says, it's almost going to suggest the other categories that we're missing. As you solve this optimization problem, we'll take other skills. If those are the skills you'd like to measure, design a second set of tests on that. Sure.
I think